My name is Christian Jacob Harrington, and I'm a teacher at Oakdale High School in Allen Parish, Louisiana. As an educator, I am passionate about making sure that my students have the skills necessary to be prepared for adulthood. And I help my students develop those skills through learning of math. Today, I invite you to join my 9th grade students and me in our Algebra 1 classroom as we learn Module 5, Lesson 21 of the Algebra 1 Eureka Squared curriculum. Lesson 21 uses the context of the world population to help students write equations that model functions. Not only do we write equations that model functions, but we also make sure the equations we're writing do accurately predict the data before then using those equations to make predictions. This lesson relates to the overall goals I have for my class because it teaches students soft skills that they can apply in various aspects in life, such as being precise, double-checking your work, taking multiple approaches to solve a task, among so many other things that you'll see incorporated into the lesson. Now, prior to this lesson, my students do already have some experience in the knowledge required for this lesson, such as the types of functions, how to write explicit formulas to represent functions, and how to use graphing technology to write regressions to model functions. Now, as a teacher, I prepared for this lesson by making sure I knew what the desired outcomes of the lesson are. So I looked at my exit ticket, debrief, and objectives to see what really should the students be learning by the end of this lesson. After doing that, I combed through all the problems in the lesson to see where my students might struggle to where I could modify those problems and provide some scaffolding. I also considered where my students could use a bit more independence and where I could modify the problems to look more like a real-world situation. As far as the students in my class, they're very bright, promising young individuals that really have learned to monitor their own behavior and make decisions that promote their own success. But with that being said, they did come in, or the majority came in at a level that really wasn't proficient for grade level. So we've had to fill in some gaps along the way, and during each lesson we incorporate prerequisite content while still trying to meet the main objective of our Algebra 1 lesson. With that being said, that has affected our ability to practice a lot of the Algebra 1, but we have covered all the material that we needed to for Algebra 1, and that's something that we can be proud of. So every day, kind of modifying as we go to try to meet their needs and catch them up to speed. We also incorporate other adaptations into the lesson to help meet their needs, such as number 1, grouping. I group the students strategically to where we have students that are strong in certain skills in each group, to where students can capitalize on each other's strengths and help each other out in a peer support system. I also make sure to scaffold the lesson appropriately to where everybody can access each problem. That might include representing the problem in a different way or explaining the problem in a different way than what might be in the workbook. And also, I've shown students multiple approaches to complete a task, such as using graphing technology versus recognizing patterns in a table versus using guess and check. So students really have learned to be efficient in their approach by looking at multiple strategies and choosing their preference. Other relevant information for the course is just that we make sure that to try to cover all our needs from prior years while also meeting the goals of the Algebra 1 course. And sometimes that requires some modifications, but we are thriving and working ahead as best we can with the resources that we are provided. So we do invite you to join with us today in Lesson 21 as we learn to write equations to model functions. All right, everybody, today we are learning Module 5, Lesson 21 over world population predictions. Everybody please pull up your course schedule and we're going to see what our goals are for today. All right, so if you look at our course schedule for today we're going to be taking data from functions and writing equations to model that, which we've done all year. Let's start off by seeing if we can review some of the different function types we've learned. Discuss with your group in about 20 seconds the different types of functions. What are the different types of functions? Go. All right, so we're going to share out the different function types. Does anybody want to share one first? Which guy? Quadratic? Linear? There's one more big one we've learned. Exponential. And we've also learned some more. Alright, so we've also learned how to write equations to represent those different types of functions. So what we're doing today is we're taking some real-world data. We're going to determine which function type best represents that data. And then we're going to use that data to write equations that we can then use to make predictions. Alright, let's go ahead and pull up your exit ticket for today to see what kind of questions you should be able to answer by the end of today's lesson. Alright, so the first question on your exit ticket gives you some data about the year and the world population in that given year. So some big numbers there. Alright, and I want you to write a function, specifically a linear function, that models the world population in billions of people as a function of the number of years since 2000. So f of x equals, and you have to tell me how you get that calculation. And this one wants to be linear. All All right, on the second question, you're gonna write an exponential function that come on that data. So you're gonna learn how to write both today, but then we're also gonna determine which one is more accurate to represent the actual data we're seeing. And that's what we should be able to do by the end of this lesson. So let's go ahead and get started. In your workbook, let's open up to problem number 1. Here's some things we consider. Now, let's think about why we're doing this in our lesson today. Today's lesson, we're using world population for all of our different problems. Why might we want to know what the population is going to be 10 years from now, 20 years from now? So I want you to discuss with your group why that might be important information to predict. All right, so discuss with your group, why might we need to know the population 10 years from now, 20 years from now? Group. Let's somebody from this group share why might we need to know the world population and predict that 10 years from now, 20 years from now? Resources are a good one. That is true. What type of resources are you thinking? Very true, yeah. If we have more people in the world, don't we need more food to supply to feed those people? Don't we need more fuel to use? Also, if the population shrinks, that might be important to know as well. So, what changes could a population decrease cause? So the population decreased by a certain amount. What's that going to do to a community?
Made up those times.
Yeah. So not only do we have all these empty buildings, but we also have empty businesses, right? If you don't have a consumer base to support businesses, then you're losing money. So they're going to move out, right? So like, let's say a business is in an area and they think the population is going to decrease a lot in the next 10 years. They need to think, well, do I need to stay in this area and where I could possibly lose money, or do I need to relocate somewhere else? So even businesses predict the population because it affects their bottom line. Also consider a lot of resources in the community are fueled by taxpayer money. So if you don't have a big tax base to pay into and pay taxes, then you can't support what's already there, like paying for schools, police departments, fire departments, things like that. Prediction really truly is a guess. What do we base our guess on? What are you thinking? Old data. That's very true. Old data, right? If you can see a trend in what happened in the past, and that's happened for 10 years. Isn't it likely it's going to happen next year as well? That trend's going to continue. And if you get new data, you can add that in and make a prediction even more accurate. That is very true. So that's what we're going to do today. We're going to use past data to see if we can notice a pattern. And if we do, along with new data, we're going to use that to make predictions for information that comes out. That's what today's lesson is about. So let's go ahead and get started. Let's look at problem number 1 in your lesson, okay? All right, so we're going to start off, I'm going to tell you the world population in 1959. The world population in 1959 was about 3 billion people, okay? Then in 1999, the population was about 6 billion people. I want you to write an equation that you can use to predict the world population after that. And you may work with your group mates. All right, so I'm going to give you time to work with your group mates now. I'm also seeing a lot of people are trying to figure out if the world population changed in that time period, then what type of change was it? Was it increasing at a constant rate, a percentage? Are we multiplying a population to get the population after a certain given amount of time? So let's think about what you want X to stand for. Any ideas so far? What you want X to stand for here?
The years after.
All right, number of years after 1959. Okay. All right, does anybody have the value of X is 0? 3 billion people, right? Does anybody have for 1999 what X would be?
6.
All right, the world population is 6 billion. And what would the X be for 40 years later, right? Okay, so if you're doing this, then I noticed that some people were finding the rate of change, how much the population increased in just 1 year during that time period. Was anybody able to find how the average rate of change there?
I got 0.075.
All right, so 0.075 billion people per year, right, on average. It's saying, what if we don't know it's increasing at a constant rate of 40 years? What if it's increasing by a certain percentage? Like an increase of like 50% more people each 40 years, or 90% more people each 40 years. That would be an exponential function, right? So let's write a new function, function h, that represents that if it were an exponential function. All right, and I notice ours is a little bit different. So y'all can compare yours. Share which one you have. Share yours with your group, and y'all can talk about which one you think is better. Yeah, that's a good one. Not necessarily. It's fair. If it's 2 years, we do 2. It's a number of years. Yeah, exactly. And then once y'all have it, check it out. So what type of pattern might we see in the table? We're repeatedly doing what? Well, that would be linear arithmetic, right? So if it was geometric, there might be a different type of math going on there. Multiply by something. Think about what you multiply by. Now you write that in the equation. What could I do to help you further determine more points? Exactly, add more data. So this is what I'm going to do. I'm going to give you a predicted value that the United Nations made. The United Nations predicts that in the year 2057, the United Nations predicts that in the year 2057, based on their models, the world population will be 10 billion people. So knowing that, I want to know which function better predicts the world population. Function F or function G. Alright, so anybody should be ready for me to call on them. So I am going to call on somebody at random, so make sure you know what your group discussed. So everybody should be ready to explain based on what your group discussed. It could be you. So do you think a linear and exponential function or neither would model a population over time? Alright, why are you thinking exponential is? Alright, and now this is a percent, right? So this is what you're multiplying by from year to year. This is like the growth factor. Alright, do we notice a common ratio or a common growth factor from year to year?
They all go down by 2 except the last one.
So it's not the same from year to year, huh?
Yeah.
Okay, so we're not multiplying by the same factor from year to year like we would an exponential function, huh? They're kind of similar, but we also notice a pattern where it's getting smaller and smaller every year instead of staying the same. Okay?
So maybe exponential.
So maybe not exponential. Okay. So I'm hearing linear. Why do we think linear?
Wait, I think it's linear.
Or why do you think it's linear?
Because there's no linear, like, I don't know. There's nothing shown as linear. There's something that's missed.
Give me some though. A linear function or exponential function might not, neither one might not perfectly model data, right? If you wanted to use one or the other, how would you determine which one might be better? Besides just information here.
Looking into your calculator.
Yeah, maybe write equations for it and see which one best accurately models the points, right? Since we wrapped it up, we're going to go ahead and take 5 minutes on your exit tickets. So I need you to do lesson 21 exit tickets for me, and we're going to recap in about 5 minutes. In the missing segments of the teaching video, students continue to work in groups to write equations that could be used to make predictions, and to verify that the equations they write could be used to make accurate predictions for the given data. After the lesson, I analyzed the students' digital exit tickets to assess for understanding, and that is how I knew the objectives of the lesson were met by the majority of students. 75% of students in the class correctly answered all questions on their exit ticket assignment, in which they were asked to write equations that could be used to make predictions given a set of data. 25% of students struggle with simple concepts, such as rounding, formatting, and understanding what the constant of the equation represented in context. I addressed these students directly at the beginning of the next lesson to clarify any misunderstandings. In the next class lesson, students were also going to complete a quiz, but before the quiz, we did a review of prior concepts. Students were asked to write equations for real-world data that they had to research, and to justify their response and their prediction using technical, precise terminology, which also helped other students in the class better understand the material. In the future, if I had to redo this lesson and make some changes, I would probably make sure that all students in the lesson were engaged by assessing for understanding even more during the lesson than I did, and writing down the names of any students that were struggling with writing the equation themselves. So that during the debrief, I could work with them in a small group, and then they could go back and report to their group what we discuss in our small group. This would motivate these students to make sure that they know the information and don't get left behind. During the debrief, I would also have students interpret what each column of the table represented before determining what type of function was represented by the data, so that students weren't confused or confused by any issues with understanding what the different numbers in the table represented. And lastly, I would make sure to ask questions in different ways so the students would know how to apply those skills they learned in the lesson in various contexts. So for example, I might ask students, in what year is the world population expected to reach 12 billion or 15 billion people? Or what is the predicted population of the world in the year 2055? So I'd make sure that students can apply what they've learned in various contexts to see how that information is useful and applicable in the real world. Thank you for joining us today, and we hope to do better the next time we teach a lesson.